Great. Okay. So today's session is our Data Warehousing 101. We've got quite a lot to rattle through. So yeah, get the introductions out of the way, although I think most of you know me from various places. We'll cover off what a data warehouse is, some of those core concepts. We'll then actually build a warehouse out using Braggy, which is a tool we've written at Cortex. I'll set the scene, kind of give you an overview, kind of what we're going to build, and then we'll build that out. It's part way built out already, and then depending on how we're doing for time, I've got some slides for some buzzword bingo, other kind of just terms associated with warehousing. If we've got time, we'll run through some of those. If not, we'll skip that and we'll just do Q&A. Welcome questions as we go, so do fire them across. That's a younger photo of me. So yeah, I'm Mark. I've been a geek software engineer for about just over 20 years now. Website profile needs updating. Last 4.5 years, I've started Cortex with Matt Thornton, who's got COVID and isn't here today. My 20-year career has been largely bespoke development. The last 10 years or so has been pretty much solid data warehousing for clients, businesses with, some of them hundreds of clients and others millions of clients. So it's, full range, but a lot of the warehousing concepts obviously apply to businesses of all sizes. Cortex is quite a small tech consultancy company over here. We're split currently between doing the tech consultancy and investing about half our time into our own IP, one of which is Braggy, which I'll show you later. And you may have seen seeker.gg. That's an aggregator site for Guernsey that we created some time ago. We're a tech-loving company, so there's 5 of us, 3 of which are here. We all love the tech and relentlessly try to keep up with it all. So covering, I guess, what a data warehouse is. It's a centralized data repository. Its purpose is to pull data in from disparate sources across your organization, so you get it all in that one place, so that you can join it all together and make sense of things. So most businesses obviously have many line of business systems, OLTPs, those online transaction processing applications, and those are very much from a data point of view designed for processing data, for writing data, inserting, updating. It's for actually just modeling processes really, rather than querying. So our data warehouse looks to pull all of that data into a central place. It's got a time aspect to it, so it'll track it over time. And it's a proper source of truth. So source systems do all sorts of strange things with data patching and whatnot, where your warehouse will actually just snapshot that single version of the truth and allow you to analyze data and help your business make decisions actually with that holistic view of the entire business. Obviously, a warehouse mashes all the data together, if you like, and creates a number of models, or they're often called data marts. And then those data marts kind of get exposed out, and then you'll connect various reports, analytics, BI, or just exports that get consumed by downstream systems to be used. But in my head, a warehouse is much more than that. A modern warehouse needs to be agile, so you need to be able to develop fulfill multiple requirements at the same time. So you might have marketing hammering you for something. Your finance team might be wanting other processes, modeling data pulled in, or asking questions of the data. And a warehouse needs to be able to allow you as an IT department, development team, and analysts to actually run those in parallel. So it needs to be very agile. It's got to be flexible these days. So you don't know what questions you want to ask of your data. So obviously very topical, all of our clients are frantically looking at their exposure to Russia. So they've been asking, the questions of that data in the warehouse, which you won't necessarily have built that in up front, but you've got all of that data in there in the one place. So it needs to be flexible in so much as you don't know what you need to ask it when you build it, but it should be flexible enough that you can ask questions like that on the fly. I mean, one of the other ones that's just come up last week actually was one of our clients had a demand, if you like, from the Swiss regulator. They wanted to know which their clients had a transfer of ownership in 2020. They wanted to know what the value of their account was at the point of transfer, and they wanted to know all of the transactions that occurred in 2020. And as these regulators tend to do, they don't give you much time to do that. The line of business system that the data lived in, it would never have been able to answer that. But the warehouse in particular there has been building up data for about 10 years now. So it was able to do that, and it was a couple of hours work of hammering the history and to pull out the data they need. The automation side of a thing, a warehouse is key. A lot of, we'll look at I guess that data pipeline of getting data into a warehouse and onward. A lot of that work can and should be automated. It's just boilerplatey type code that's hundreds and hundreds of lines of code, but it's the same rinse and repeat sort of stuff that if you had to do by hand, you'd cock it up. I mean, it's fraught with a danger of making the copy and paste errors there. But also just to coordinate all the things that need to happen. Obviously, pulling data in from tens of systems potentially, that all that needs coordinating. And then when you're onward processing that into your models and your data marts, then you need something to kind of coordinate all of that. Obviously, productivity there is a key one. You've got to be productive with any modern technology. You don't want to be bogged down with the grind there. The last one is arguably, I think, the most important, really, in my eyes. So it's data traceability. So a modern warehouse should allow you to look at where data flows all the way through from start to finish, and that's important for many reasons. Obviously, auditors are a bit like dementors, but when they come in and hone in on kind of getting their audit satisfied, they'll ask you for how you've arrived at a figure that might be on a valuation report or something, and you've got to show how all the transformations that may have gone through in the warehouse, but also where it's come from, and it might have come from multiple different places to get to that end result. So having that traceability is really useful. Well, integral really for auditors, but also things like source system changes. So often a source system will obviously do things to you. They'll upgrade. We've had bloody client tables get nice big wide client tables split out into a narrow one with 4 or 5 extension tables. That's a fairly fundamental change that's going to impact your warehouse bringing data in from that. So being able to, again, just do that track forward traceability and say, well, where is all this data going once it enters the warehouse? And you can see all the models that are impacted so that you can plan for that change. So data traceability, I think, is really, really important. So starting to look now at the pipeline. So you've got to get data from a source system into the warehouse, and there's 2 really main approaches for I guess acquiring the data. There's ETL, which is extract, transform, load. That will pull the data from a source system, but transform it on the fly. And this is an older approach, but still, when people talk about getting data into a warehouse, it's ETL. But the reason they used to transform it is to prepare it for, I guess, use in the warehouse, and just, I guess, optimize. But also, I guess in the 70s, 80s, 90s, it was about trying to condense the amount of storage space that would take up as well. So that would yeah, maybe apply some data quality, shape it, so throw some of the columns away because they didn't think they need them, maybe aggregate some of the figures up, and then pull that into the warehouse where you then consume and use it from there. The much more well, kind of modern and current way of doing it is to just extract the data from the source system in its entirety, get it into the warehouse, and then from there you can transform it and do what you need to satisfy your current, I guess, your set requirements. But again, that flexibility, if you've got the entire data there and you've got 5-6 years of history there, and someone throws something from left field, you can remodel and you've got the information there to do what you wish of it. And also, I mean, this saved us so many times that you've got a source of truth. If you take that data from a source system, put it into into warehouse, and you're tracking that over time, so that you can say, no, that is what you gave me on that date. It saves, makes investigating things a lot easier if you can get down to that point and say, no, that was you. And we've had cases of that saving us, as I say, countless times. Yeah, some interesting ones with one client which was doing obfuscating data in a source system with GDPR now, but they were almost corrupting the data over 2 days whilst they were obfuscating it, and we were bringing it in, but we could see what they were doing to it, and could help them actually figure out and pinpoint, well, it's you did something this night and it did this to the records, and then it was mopped up the following day. So yeah, the ELT is the way forward, and I've got a little GIF that I've nicked off the internet, but that kind of shows where that transformation is happening. So yeah, it's before it comes into the warehouse for ETL, and then obviously within the warehouse for the ELT, and that's you'd always suggest going down the ELT route. It's not always possible, so it's sometimes you have to with if you've got massive volume of data, potentially you couldn't bring it all in, but yeah, very, very rare, and you can do both. So once you've got your source data into the warehouse and into the load area, you then need to change track it over time. And there's 2 types of archive table there. You've got a transactional type and a change tracker. Transactional, we'll look at actually next. That's more like your bank statement, and a change tracker is your client record, which will move over time. And you can, I guess the key thing for a change tracker is to do it efficiently. So you're not, well, have seen businesses where they'll snapshot an entire table every day, and wonder why they've got terabytes of data in their warehouse, which is a nightmare to process then as well. So this is your standard transactional archive table. So both types of archive, they require a business key. And so the business key is your primary key, and you can use that to determine whether or not you've seen it before, in the case of transactional one. So if you've got your archive table from yesterday, you've got your new load that you've brought in today, you can compare the 2 to see what's new, and obviously then bring the new records in, and add those new records. So here, oh, my cursor does work. So yeah, there's obviously a chunk of data arrived on the 21st. This blue column is one that would get added to the warehouse that you can record when it arrived. Again, never trust a source system to tell you when stuff actually happened. So it's got order dates on here that you think you would be able to infer that from, but they can backdate things and patch data and do all sorts. So yeah, a warehouse should always snapshot with timestamps so that you know exactly when things did occur. So yeah, for transactional, you typically just add the new data each day, and that would just get appended to the table. You can get a transactional one to update rows that have changed, but yeah, generally don't really want to do that. But yeah, if it's just a transactional table and yeah, maybe it does get patched, it's obviously patched for good reason. You can always use a warehouse tool to just automatically update as it comes in as well. So the archive for a change tracker, again, I've added these blue fields here. So yeah, those record when a record arrives, a version, so you can quickly order it to see the order of events, and then each record has a period of time that it's active for. So obviously record 1, it arrived on the 28th and it disappeared on the 9th of December. And you can see you know, what changes between them. So I've highlighted these in yellow. So version 2 came in on the 10th with a status change. Looks like that fell through. And on the 1st of March, it moved back to available, stayed like that for a week. And then on the 9th of March, they dropped the price. And that also triggered a change in PDF details. So this is, as I mentioned before, we've created Seeker, and Seeker's, you know, sat on top of a data warehouse, if you like. It acquires all the data from all the estate agents, and that gets pulled into a load. And then we archive each of the estate agents' details. Yeah, and yeah, we presented them with information like this. So this is really useful for us for, you know, running Seeker, because we can, you know, if you, well, I should have logged in, but if you log in here, it gives you the insights. It'll tell you that you know, the property price has dropped twice since it's been on the market, when it first arrived and stuff like that. And that is all, you know, obviously very easy for us to acquire from, you know, an archive table like this. Yeah, and the warehouse obviously just, you know, manages the process of tracking these changes for you. As I say, the key thing here is it does it efficiently. So it's not creating a new version every single day. It's not having to update dates on all the records every single day. If it sees a change, it'll then update the state in the archive table. So yeah, data flow describes, so you know, you've got your disparate sources down the left-hand side. You bring those into load. So you'd have a load table for each source table. So obviously for a file, it would be one-to-one. A file would have its own load table. Each table within a source system would have its own load table, but those all get brought into the load area, and then those would then get, you know, change tracking into one of those two archive types. And then once you've got all of your, I guess your universe has refreshed, you can then rebuild your models. So stages are very transient. So you throw those away every day, you truncate them, and then rebuild your view of the world. And so typically stages, you know, most stages will, yeah, model current position, but equally you could have a stage that, I guess, gives you your year-end view or your set of year-end snapshot, you know, and that runs once a year. But yeah, the stages reference the data in the archive table. So you'd never reference the data in the load. Loads are also transient. So the load will typically get truncated before load, so that you know you've got that set of data is clean and mirrors exactly what's in the source system. But your end goal is, you know, moving through the staging process, and a staging process will have multiple steps typically. So, you know, some of you know, to prepare clients, a client view for consumption by your models, you would you know, probably go through 10 plus steps to actually gradually shape, you know, and aggregate data into it. So so you're using, I guess, a client, you know, as an example, you might, you know, pull their, you know, name, status, nationality information from a client table. You might go and grab a set of addresses from somewhere else, and, you know, obviously the warehouse is all about optimizing for read. So you might, you know, stick the addresses on the end of that client record so it's ready to be accessed quickly. You then may go and look at all of the relationships they've got with, you know, financial products. If it's a financial system, move them all into a base currency, aggregate the amount, and then obviously stick that amount on the end of each of the client's records as well, so you know how much you know, that client is worth to you as a business. So that's, you could do in one query, but the query would run horrendously. And if you break it down into small chunks, it's obviously much easier to manage and see what's going on and satisfy, yeah, the auditor dementors, because it's all just nice step by step. You've got the reporting and analytics, then that's outside of your warehouse. So that is very much deliberately on the right-hand side. That would read, pull data from the warehouse that you've prepared, and do your visualizations. And you've got there's countless amazing products out there for that. So you've got your Tableaus, Clicks, and Power BIs for the pretty little visualizations. You've got OLAP cubes for giant pivot tables, or you're just squirting it out as Excel for the business's favorite tool to do what they want with it. Right, so Braggy is a tool that we've created to make data warehousing as productive as possible. So I won't spend too long doing the sales pitch, but it does the load from anywhere. So I'll show you how we can pull data in really quickly. You've got those two different types of archive table that you can set up that change tracking, and you can decide what data you want to actually change track. And then that staging, that modeling aspect of it, it manages that process for you as well. So you can quickly build out data models. But leading on to the next point, you get that data traceability, the lineage all the way through from starting the source to the end. It's got a scheduler, its own scheduler, so you can coordinate all the things so that it all gets run in order, and you can obviously split things out into separate jobs and put dependencies between the jobs. We've got a little widget in there, which is the Swiss Army knife. So if you can't pull data in from a file, you might. So one of the examples we've got now, we've got a fuse where it's got to go externally, do a little dance and pull data in either from web services or FTP files, and transforming XML and stuff. So you can do that in C#, which makes it nice and flexible. Documentation, obviously with full data traceability, you can auto-generate a lot of the documentation. Again, that's not only auditor friendly, but it's also good for onboarding people onto the team. And there's also deployment, so that you can manage that release process between your dev, your test, and your production environment. So you can separate your warehouse out and treat it like a proper grown-up development process. So we're going to go and actually build out a demo now, but before diving into that, let's set the scene of what we want to do. So I showed you my screenshot of Seeker earlier. So Seeker brings data in from all the estate agents' sites for the property side of things, but it's also pulling data in from the graph. So we've got sales data and bonds issued data from the graph. So that's all publicly available. All of that gets archived and change tracked over time. So the purpose of this little demo we're going to run through now is to, I've brought some of the data in, but I'll show you how to pull in a table from the Seeker database. So that's running in Azure. And I'll also build the import mechanism for the Excel file that contains the list of bond data. So that comes in via Excel. So that will come in as loads. We'll create archive tables for the two new things we're bringing in. And then we'll bring a very simple model. We'll enrich our bond information with some friendlier bond issuer names and the like. We'll calculate the LTV for all of the properties that have been linked together. And then we can aggregate them up and look at what the some key stats by parish, by quarter. So that was kind of just simulating something you might want to do within a business. So once you've got that little model staged out nicely, we'll then stick a view in front of that. So that's we use views very much to as I guess a contract and interface between the warehouse and the outside world. And then from that view, we'll generate an extract to just get written to disk. That could be one of many different types as well, which we'll look at briefly. So that's, I guess, setting the scene. Right, how do I come out of here? Got no escape key. There you go. Right. Okay, so this is Braggy, so I'm going to have to face this way a little bit and dodge the sun. Braggy, you set up connections to the systems you want to pull data in from. It has a connection to the warehouse repository, so that's tagged as the warehouse, so you can only have one of those. So that's where all our data is being written to. Let's just make sure that's still working there. And then test seeker, let's make sure that works. Cool. So we've got connectivity to seeker, great success. And I'll show you quickly what we've brought in already. So we've got the bond issuer data, and we've also got the property prices data. So that's just got, it says here, the address, parish, data sale, and how much it's for. I've created archives for those already, but let's just go bring in the two new sources we require. So, right, let me just, where did I put that? Sorry, bear with. So we want, just copy that. Right. Okay. So that's the file we're going to bring in. So yeah, that's just on, that's locally on my disk. The location is accessible by the scheduler. So I can put, well, before we go into that, so yeah, so that's pulled that data in, and maybe if, where have I put it? There it is. If I just open that up, so you can see what's in there. Some weird Excel thing going on, but yeah, there is all of the data coming in. So it's got codes for the who's issued the bond, how much it was for, and all we know at this point really is who the bond's been issued to. So that's going to get hoovered up. Don't save that. And so that, as I say, is pulled in. So what Braggy's done is it's analyzed all of the data in there, and it's inferred what the data types are. So we can see here, obviously borrower 2 has something in there that's bigger than borrower 1. So if it thinks that's big enough for a borrower, then we should probably set that there. So it's not quite got the bond amount right here. So that I know is a numeric. So I'm going to change that. So these will need to be reviewed, but you can look at what your values there. So the range of values is 0 to 125 million. But yeah, you can flip through and actually just look at the range of data you're seeing in various fields, and it will tell you how many distinct values and stuff that you have there. So yeah, so there's 27 different issuers used across this file. Once I've set that up, so you have to review this really, because obviously if you in the future you get new data and it's going to be wider than some of these columns, it will fail on import. So you do have to review them, but Braggy will give it a good stab. And get it somewhere close. It looks at the max value, and then it looks at kind of a boundary value, and it gives you some capacity there. You need to specify where it's pulled the file from, which was here. And where's it gone? So that's where it's going to import it from. We can set it to archive that as well. And I know that directory is there, and you can get it to rename that. So let's save and run that. So that's what that's done. It's created the load table within the warehouse. So it's stubbed that out for you. And now it's actually just going and processing that file in the background. So we'll go and check that directory in a minute, but it'll have removed from there. So whilst it's doing that, we'll go hit seeker. And I think it's the bond to price link. So I know the key for that is the bond ID, and obviously it's linking a bond to a property price. So I'll set that. So things I guess Braggy's doing, which is pretty cool, I think, is we every connection gets a code, and it'll pull that into the table name so that you get all the objects clustered together. It's just something which, again, over time, having built plenty of these now, that's a nice little time saver. Yeah, and obviously that is what the table is called in the source system database. So again, you can just look in your warehouse, you can see load, seeker, XYZ, it's called that, it's come from seeker, and obviously the load is the type. So yeah, that one's set up. So we'll save and run as well. So here you can see it's stored the metadata and created all the things it needs now to pull that in. I guess worth stressing that everything that's being created by Braggy, it's just standard SQL stuff. It's not doing any, there's no magic code, proprietary little DLL widgets or anything like that, which you can't see. It's all just standard stuff that's created inside SQL Server. So you could go in and explore SQL Server, see the procedures that it's running. You can obviously see all the indexes and objects that it's stubbing out for you. It's all just normal standard SQL stuff, best practice, obviously, in terms of the change tracking logic and whatnot. But it's all there for you to see. Right, and I've realized, so that, this is, so so the files don't get they don't get a prefix because it doesn't come from a connection, and that I want to prefix with greph because that's where it's come from. So I'll save that. So yeah, again, this one's not particularly clever. So it's creating a table for it, but it's also creating the scripts around it that you may want to run to recreate it yourself. So let's just save that in. So that's better. So this is where I think the big time saving is. So if we just pull the greph one in now. I didn't set the business key on the load, so I have to now set it here. So the correct thing for me to do really would go back to that load and set it. But I know what the business key is. It's the record number in the greph. That's the key. And again, if we look at what that's doing, it's creating a number of procedures there to do the change tracking. It's got all these magic fields we saw highlighted in blue on that other screenshot to actually do the change tracking, and then it's got a fair hundreds of lines of code then to do the change tracking to detect changes and figure out which are new records and which ones are being updated and the like. So yeah, again, but it's all just standard SQL. You can pick your type here, but we'll just run that in. Make sure I've done that properly. So that's the bonds. So quickly create. So it's only showing me the things that haven't already got archive tables. Again, we try to make the tool just so you don't have to think and find things. But let's bring that one in. So that's got the key set already, so I don't need to set that. So save and run that. So that's our archives setup, which will start change tracking that information as it's coming in. So what I do now is, so we'll just quickly run through the tables here. So this tool, that's been recreated. So this tool here is DataGrip. It's what I use to query data and model things. So yeah, I quite like it. And these guys are smiling at me because I plug it all the time. But it makes it, it's just a solid tool, but you could use as your data studio, management studio, whatever you're comfortable with. The point of this next bit is you do your data modeling in whichever tool you find easiest to actually just write SQL. So I'm just going to make sure these are populated. So yeah, you notice that one isn't populated. So I'm just going to drop that back in there. And we'll pull it in fresh. All right. Let's see. It shouldn't take long. Cool. So that's there. And we'll just also run the archive for that. So that's not there yet. Cool, so that's there. So that's all of our loads acquired and archived, and we'll change track thereon. So what we're going to now do is just build out that model. So hopefully that is visible. Does that everyone see that? Okay. So let's just run that. So this is, as I say, it's simply enriching the raw bond data we've got from the graph and just bringing in a friendlier issuer name, just for something to do on that stage, really. But you're enriching the data and making it better. And so when we go to stage, now this is part of the magic of Braggy. So yeah, so we've written our model, we're happy with it, we test it and validate it within whichever tool you want to use. But I guess the gold here is, so that gets parsed and we've got full traceability now. So it's within the metadata of the warehouse. We know where every field has come from, so it's all recorded here. And any transformations, I mean, there's no real transformations here, but anything that's done to the field is recorded here. That'll become a bit more interesting in the next stage. So let's give it a name. And that's that one done. So what Braggy's going to do is going to wrap that little bit of logic in some scaffolding that's going to do some auditing and record how many rows are inserted and stuff like that. But let's go build out our next one. So the next one's going to calculate the LTV. So I'll put that in there. Infer from SQL, so you can see, obviously that is a bit more of an interesting transformation. So that's been pulled out. Again, we can use that then to do the traceability and documentation and whatnot. No stomach. Save and run that. So that's enriched our bond information with the issuer. We've calculated the loan to value. I mean, I didn't go through the load tables that we pulled in, but we pulled, one of them was a linking table, which we manage in Seeker, which links the bond to the actual conveyance, the sale. So that's calculated that. We'll go and have a look at that data also in a second. Finally, so we've just got some aggregation logic here. Again, you would run that, make sure you're happy with it. Make sure the numbers look sound, tease out any any issues. So one of the things I noticed was if we run this one, so this is our raw data. I mean, there's some oddities there. So obviously Guernsey conveyances, you can have family family transactions. So, but you could still get a fairly hefty bond to renovate or rebuild it, but they obviously completely screws the LTVs when it's a family sale for £1. And yeah, you've got a £440,000 mortgage on it. So, in this little LTV roll up by parish, it's, it filters out, where the sales price is more than £100. So in the graph, they record family ones typically as a 1 or a 2. So that's a crude way of filtering those out. Let's get that, inferring that. So save and run that. So we've built out a very simple little model there, but very quickly. And as I say, it's got the, we've got all the data lineage. We can see where tables have come from and where they're going to. So we can see that the 20 has got a downstream dependency on 30, which is really useful, and where the data comes from for for each one. So that is data modeling. You can stand up these models incredibly quickly, and you should be able to. Because obviously, what we typically find is when you're building out a model in a warehouse, you'll build it once, understand the data by the time you get to the end and realize you've done it in a rather daft way. But it is so quick, you can then just stand it up again, make sure you've obviously got the same results if they're correct, and then just drop your old models. So you can stand up models incredibly quickly. Obviously you can just edit that, drop it in, save and run, and it's all there. So let's just complete the cycle on this one. So we wanted to create a view just to interface that parish stats. And we'll just quickly give that a name. Stats. And yeah, so that's there, and we'll just create an export. So this is going to highlight it to, let's delete those. That's the archive export. Move that to the bin. So we'll reference that view. We'll save it to there. Oops, save it to there. Let's put that in there. And we'll export it to Excel. And then, as this kind of says here, you can include some magic variables in there, but we'll call that today. Don't put the file extension, and that's good enough. So that will spit it out to that directory. I guess the next just thing I wanted to quickly show you was we'll go and check that file in a minute, but so create jobs and tasks. So let's call it stage bonds. That's so these are the three things we've brought in. Again, because we've got all the metadata describing where data comes from, we can, so it's got these three stages. Obviously, they can't all be run in parallel. These being left aligned, all these could be run in parallel if that job was to run. But if we calculate the dependencies, 20 knows that it depends on 10, and 30 knows it depends on 20. So now we know, well, the scheduler knows it can run them in that order. So it's quite a cool way of just letting the system figure out the most efficient way of doing all of its things. So it'll figure out its little dependency tree and run all the things on the left-hand side and throw them away and just keep moving down until it's all done. So again, other systems we've used, you have to go and manually build that little dependency tree, and you insert something into the middle. It's just a ball ache, and it shouldn't be, because it knows everything. In fact, I didn't save that. should pop up something like that though, shouldn't it? So let's pop that. Add that. Figure out that. Check it. And don't forget that. So that's the export as well. But you can override and set the dependency tree, if it has missed something for whatever reason. So create that. So that's something, again, it's got a cron, so you can schedule it. Let's not hammer that home. It's got a scheduler, so the history of what we've done today. So it's all recording all the things you've built. So this is all useful. We haven't built it into Braggy yet, but we intend to kind of get it to start looking for spikes or drops in data coming in and flagging anomalies. But so that file got produced there. So that's Braggy in a nutshell. Its whole purpose is as a productivity tool. As I say, it's not doing anything that you couldn't do by hand in SQL Server, but it just allows you to build stuff out really quickly. And so that, I think, was the demo. I don't think I missed anything on that. Those are all the things we've done in this little session. So I'll jump back to the presentation. So Ben, do you want to jump back? where's it gone? On the live view, how are we doing for time? 10 minutes, that's good. Is that gonna? Right, so I think we've got time for a bit more. So yeah, on the buzzword bingo, we rattle through some of these. So obviously there's loads of other words and terms that are associated with kind of data warehousing. So data mart, I think I've covered. So that's just kind of, I guess, a very narrower focus for a given subject area within the business. So marketing and sales being examples on this one. A data lake is, so a warehouse has got structured data in it. A data lake has both structured and unstructured, but predominantly unstructured data. So, and typically that would be streamed into the lake. It would just constantly be acquiring it. So I think one of the articles I've read is, all the wind turbines are constantly producing diagnostics, which kind of goes into a data lake. And then they've got some data scientists that are trying to make sense of that, that data that's there at the time to try and machine learn and figure out when things are going to fail. So data lake has a massive repository of unstructured data, which a team of people would try and make sense of, model and push into a warehouse, and then the warehouse can use it. A data swamp is a data lake gone bad, and it's very easy for the data lakes to go bad because it's unstructured and just hoovering up data, and if you're not on top of it, I think it can probably grow out of control very quickly. I think I've got some pictures for these. So some examples of data pouring in. So even social media feeds, there's some unstructured stuff there that's feeding into a lake. Well, depending on the size of the organization, it might be a little puddle. An OLAP cube is, as I mentioned earlier, just a giant pivot table, really. It pre-calculates all of the facts, all the measurable things, get all the permutations of the things you want to slice and dice it by. So on here we've got the root, the source, and the time dimensions, and it will pre-calculate all the combinations of the data you've got at the fact level. Each day, well, it will additive, the cube will get added to each day with its new data, but then you can point things like Power Pivot and at it, and you can just use Excel to slice and dice that data up. That's quite common. That OLAP cube and a lot of models rely on these star schema and snowflake schemas. Those are the two popular data modeling forms, if you like. So the star schema, thus named because it looks like a star. You have your fact in the middle, and then you have your dimensions sitting around the outside. Dimension being the descriptive thing, and the fact being the measurable thing. So the purchase amount being the thing you want to aggregate up by the various other things. But you can look at the sum of that by product, by customer, where it was sold, and the date it was sold. So I think when you're doing your data modeling for these sorts of things, you've got your who, what, where, when, which is what you're typically looking to get your dimension for all those facts. A snowflake schema just takes the star schema, but it just splits out those dimensions so that you aren't repeating and duplicating information. So it becomes much easier for it to maintain. Slightly, it'll be more efficient in storage at the expense of being more costly to join it all together. But those are the two that are kind of vying for the throne at the moment, and both very popular. I think that's pretty much it. Bar any questions?
So you have like a web front end for Braggy, like where does it live or where can it live?
So it's written in .NET, so it can be deployed as a web app, but it also is an Electron app. So you've got a fat client as well, so you can roll that out. And we've got clients that use both. Some prefer to use the fat client, and then obviously give access to specific users for that. But another client doesn't want the pain of having to roll out software to multiple clients when we do upgrades, and obviously we're improving it in fairly short cycles at the moment, and they want to use the web one. yeah, it's all .NET Core technology. So I don't know if you know .NET Core, but there's some some cool tech coming with this next version that will allow us to build the fat client, without using electrons. Electrons obviously a little bit bloaty, but we'll be able to roll that out to an actual executable, and it runs on my Mac. It'll run on a Windows. It'll run on anything. The scheduler is just again, that can be deployed anywhere. It's
the scheduler says it has dependencies, but also to run at certain times.
Yes.
Events,
yes. Yeah. So what's time based with job dependencies. So you can so you can put a chain of dependencies on it. So for our model there, the bond stats, you could put a dependency on the seeker data having come in. So you could put job dependencies in there. We've not had a need yet to do trigger dependencies. Obviously on the file loads, it will start at a time and then wait for an elapsed period of time that you can configure. And then when the file arrives, it will then run. So it won't just fail if it's not there. It will wait for a period of time that you ask it to. But no, I mean, if there was anything funkier, then be interesting to know what you would want to do, and we could probably make it do it. Or you got the Swiss Army knife sort of thing. You could use the code component to do it. That'd be your first step and would sit there until the condition was made, maybe. But that sounds a bit hacky.
How would you deal with interface into an API?
That's what the code component is. So the code widget is we've pulled in a lot of API data now. So that it gets an optional data set you can pass in. So it will get presented with a set of data that you can iterate through if you need to call a web API for each thing in that data set, or it can just run on its own, hit an API and pull the data down. And you write it into a structure, which then gets persisted to a table. So the code, the input is an optional table. The output is it's a table called code, whatever you call it. And then you can hook that into your models as well. So that can just be brought into your process. We've used that for a few things. So IBAN lookups, some pulling in some XML data from an external site. But that's all doable.
When you do the data transformation, for each step, are you like making new staging tables?
Yes.
And you save them for traceability as well?
So the staging tables, so they do all get persisted for the day. Obviously, as they get rebuilt, they get truncated and repopulated. There's a separate database with the metadata in, so that's got all the data or metadata in there for the lineage stuff. But yes, so if you looked in your warehouse, you would have stage 10 client, master, stage 20 client, enrichment, and an FX, and you get all of those in there. But that's actually quite useful for troubleshooting. So if you've got a troublesome record, we had it the other day, so you start obviously at the end, look at the data for that client, and then you just keep going up the model until it looks squiffy. So it does help kind of troubleshoot what's going on with them.
Can it hook into an existing data warehouse if you're looking to expand a new source or something?
Not something we've looked at. I think you'd possibly. Is it a homegrown warehouse, or is it a one that's is it another product?
No.
Yeah, so you could probably, then you could retrofit a lot of the stuff into it. It would be a bit of work up front, but you can obviously if it's homegrown and you're running SQL that does things, then you might have to change the approach to some things. But again, it kind of so we've done that actually for one client who had about 15 common table expressions all at the top, and then a lump of SQL at the bottom, and it would it'd take 40-50 minutes for it to run. we pulled that out into separate stages and then processed it, and overall it ran in 5-10 minutes because it just did it differently, but it did require a bit of work to kind of rejig it. But yeah, I mean, there's no reason why it couldn't run in parallel. Obviously the other warehouse processing bit would have to run its things, and as you could port it across over time, I think. But yeah, it'd be worth exploring. You look poised. Yeah. Grant? Nothing else? 3 minutes. So, no, that is good.
I mean, do you kind of sell this as part of like this little consultancy package thing, or do you sell this for?
So I guess, yeah, giving you a brief background or history for Braggy. So Braggy came about because we wrote Seeker initially, so it's just like we're not writing this code again and again, so it's just like create a tool to create it for us, just the archiving procedures and stuff, and then obviously it just grew arms and legs from there, and then it's got the loads, and then it's got the archive, and then it's got a scheduler, and then it's like, oh, wouldn't it be cool to do the stage? So it's kind of just grown and proliferated from there. But to answer that, no, well, we're not looking. We obviously will help on the consultancy side to kind of get it in. So we normally, come in and kind of just get, because some businesses that are using it are very, I won't say immature. It's their first foray into warehousing. So it's, we help them just get it seeded, but it doesn't take long. So I mean, the last client we've got, it's not you. Spent 2 mornings with them just going through the bits, and we just did it together, and then went back a week later, and he's got 92 tables brought into it now, load and archive, and he's now starting to sit the staging on top, which he used to run against the source systems themselves. So some time, a bit more time to go in and show him how to do that point in time analysis now, so that he, if he wants to run it for year end, just the SQL to do it with, it's not complicated. It's once you've seen it once, it's a click sort of thing. But yeah, it's we envisage it being a product that is better documented than it is now, and can just be installed, and clients just up and running with it. It's not a hook for us to get consulting time. So the purpose of Cortex is to try and become a software company. Yes. We don't want to be beholden on the consultancy side, but obviously that's going to be a part of trying to get this in and used properly. Excellent.